Set number 11, double integrals part 3. We are going to talk about volume. Let's suppose we have some region in the xy plane. There's a rectangle. That's as far as we can go in this section. And we have a function, z equals f of xy. This could be any function that forms the top. We have straight sides formed by this rectangular boundary. You can draw this top, this tall, skinny, what's called a parallelepiped. The dimensions of this would be f of xy would be the height. I didn't write it in here, didn't want to clutter my diagram. dy would be this little dimension here, or that would be dx, and then dy would be this little dimension right here. And of course, I assumed x is going to go from a to b and y is going to go from c to d, just like before. Then the volume is just integral from a to b, c to d, f of xy, dy dx. Pay special attention, the integral in the dy dx integrates over this rectangle, but when you put the function in here, you're adding up volume elements and not area elements. So this could represent mass. If this height represented density, then this would be a mass integral. This height represents just height. Well, it's a volume integral. So for instance, we stay pretty simple in this section. Find the volume under z equals 10 plus x plus y, and with base r equals 0 to 2 and 0 to 5. I could sketch this, but it would be a rectangle situated in the corner here. Now this would be a plane. It would be a linear surface. It would start at 10 and it would slope upward. So it would look like an interesting building with a sloped roof. Well, quite simply, the volume is a double integral 0 to 2, 0 to 5, 10 plus x plus y, dy dx. Integral 0 to 2. Now we have to integrate inside. 10 dy is 10y. X dy is xy. And y dy is y squared over 2. And that's from 0 to 5 dx. Now we plug in 5, we get 50. Integral 0 to 2, 50 plus, plug in 5 here, 5x plus, plug in 5 here, 25 over 2 dx. Now you can simplify things if you want. This 12 and a half plus 50 is 62 and a half. And so we get 62.5x plus 5x squared over 2. And that's from 0 to 2. And you can plug in 2. 2 times 62.5 is 125. Plus, plug in 2 here. 4 over 2 is 2 times 5 is 10. Yeah, we get 135 whatever units. This is math class, so we don't use units. But it'd be cubic whatever. If the XYZ were meters, that would be cubic meters. So simple as that. We don't have to get any more complicated. Volume integrals can get more complicated. If I said find the volume bounded on the sides by something, on the bottom by something, on the top by something, 3 different surfaces. It can get complicated, but this is a beginning section. As time goes on, we'll find volume of all sorts of interesting solids, including really interesting solids in spherical coordinates. But that's it for this problem set.